Hello everyone, I'm about to do question 8 from the 2024 June Common Test, which was written in the province of Eastern Cape. This video will mainly focus on Euclidean geometry. So I'll do question 8, 9 and 10. Okay, let's work on question 8, right? Okay, I'm given a diagram below. The circle having a center at O. Immediately when they tell me about the center, I must mainly focus on two theorems. The one that says angle at center is 2 times the one at the circumference, and the other theorem that states that line drawn from the center to the midpoint of a chord is perpendicular to the chord, and the inverse of that theorem, whereby a line drawn from the center perpendicular to the chord is that line bisects the chord rather. Okay, so here I'm not told about any line perpendicular to the chord or bisecting the chord. Okay, that means for now I need to keep that theorem at a pause, and then focus on the one that states that the angle at center is 2 times the one at circumference. Right? It simply means that since chord TU subtends O1 at the center, the same chord subtends angle S at the circumference are together. So angle O1 is 2 times angle S, right? Okay, I'm told that PUK is a tangent to the circle at U. Immediately when I'm told about the tangent, I need to consider two theorems in my mind. The first one, it states that the angle subtend the first one states that uh, the angle formed by the combination of a tangent and a chord is always 90 degrees. Why? Because tangent, not chord rather, but radius, because a tangent and a radius are always perpendicular. The second one, it's the tan chord theorem altogether. The angle between the tangent and the chord is equal to the angle subtended by the same chord at the circumference altogether. So here we can simply say that since angle U5 is between the tangent PUK and chord TU, so angle U5 will be the same as angle TSU, which is 75 degrees. Why? Because of the tan chord theorem. Are we together? And another angle which is equal to 75, since we are told that TS and PK are parallel to one another. Okay, whenever you're told that you have parallel lines, you need to look at 3 sets of angles. Are we together? Firstly, look for corresponding angles. If they're not there, it's okay. Look for co-interior angles. If they're not there, look for alternating angles. Are we together? One of the 3 or 2 of the 3 will be there immediately whenever they talk about parallel lines. Okay, are we together? In this case, we do have alternating angles, right? Such that this angle here will be equal to angle 75. Why? Because they're alternating. They form a Z shape there. Are we together? Yeah. So this is how you can go around with this question, and U5 is also equal to this angle T. So that entire angle is 75 because they're alternating with angle U5. Are you together? Okay, let's work now. Let's work. Okay. I'm asked to calculate with the reason the size of angle O1. Angle O1 is the angle at center. Okay. I know that the angle at center is 2 times the angle at circumference. So angle O1 is going to be 2 times the angle of TSU. So angle O1 is going to be 150 degrees. Angle at center is 2 times the angle at circumference. Are you together? So they want me to find angle U5. Angle U5 is equal to 75 degrees. Are you together? Why? Because this Tan-Court theorem okay, now they want us to find angle T1. Who is T1? Okay, angle T1 is there, ne? I know that this angle here is 150 degrees altogether. In that triangle, I know that OT is equal to OU. These are the radiuses of a circle, right? And this thing simply means that T1 is equal to angle U4. Why? Because triangle TOU is an isosceles triangle, and it's isosceles because OT is equal to OU. So I can simply say angle O1 plus angle T1 and angle U4, they will add up to 180 degrees. Right, together. The reason behind that, I can just say sum of angles of a triangle. Right, together. So whenever I see angle O1, I'll just put 150 degrees. Right, together. I have plus T1, which I want. Whenever I see U4, I can put T1 as well, because U4 and T1 are equal. This is equal to 180 degrees. Therefore, 2T1, 180 minus 150, we get 30 degrees. And then angle T1 is 15 degrees. All together. So angle T1 will be 15 degrees. The working is right up there, right? So now they want us to find the angle V. How can we find V? Let me create room for me to write there. How can I find V? Okay, angle V. If I can find the whole of angle T, it will be easy for me to find angle V. Why? Because TSVU is a cyclic quad. So I know that opposite angles of a cyclic quad are supplementary, right? Okay. The whole of angle T is equal to angle U5. This thing is true because these are alternating angles, and they're alternating because TS is parallel to PK. They're alternating because TS is parallel to PK. So this thing simply means that T is also 75 degrees right together. However, angle T plus V, they must add up to 180 degrees. These are opposite angles of a cyclic quad. I'll just write CQ there. Right together. If this is 75 degrees, I don't know this what this one is. I can simply say therefore angle V is equal to 105 degrees. So V is equal to 105 degrees. Opposite angles of cyclic quad. It's important to name which cyclic quad you're talking about, right? Because sometimes you can have a shape that has 3 or more cyclic quads. So of cyclic quad TSVU. Okay, now they want us to find the size of angle U3. U3. angle U3. How can you find U3? Okay, please erase here. Remember that here we calculated the size of angle T1, right? And we said T1 is equal to U4. So if U4, if T1 is 15 degrees, it simply means U1 is also 15 degrees, right? But we've just shown that the whole of angle T is equal to 90, right? Together. For us to find angle U3, we can find angle G2 first. Now I'm writing the answer. G2 is an exterior angle of this entire triangle. Are you together? G2 is an exterior angle of that triangle, right? So if G2 is an exterior angle, it simply means that G2 is equal to angle T plus angle U4. This is an exterior angle of triangle UTG. Exterior angle of triangle UTG, right? So T was found to be 75 degrees, U4 is 15 degrees. Simply means that G2 is 90 degrees. Okay. After proving that G2 is 90 degrees, we can therefore find angle U3. We know that 90 plus 75 plus U3 must give us 180 rather, because of the angles of a triangle. So we can simply say U3 plus G2 plus T SU 180 degrees, right? So angle U3 will be 180 degrees minus 75 degrees minus 90 degrees, and then you'll get what? 15 degrees. Are you together? So angle U3 will be equal to 15 degrees. Oh wow, they want us to find G3 now. Or G2, but we did find G2. Our duty, guys, we found G2 here first before we went and found U3. Maybe there was a quicker way to find U3, right? Okay, let's deal with that quicker way. Already, guys, we know that this is a tangent. It simply means that if the whole of angle T is 75, that means U2 is 75. Tan chord theorem. I don't have space to write because of tan chord theorem, right? But U3 and U2 are equal to 90 degrees. Why? Because these two are perpendicular, tan radius. Are you together? So we can find U3 by just saying U3 plus 75 is 90 degrees. Therefore U3 is equal to 90 minus 75, which is 15. Okay, we could have just used the tan radius rule to get 15, but it's fine, we did get 15. Okay, and then now they want us to find G2. G2, you can just repeat this step to find G2, guys. There's nothing wrong. We know that angle G2 is an exterior angle of triangle UTG, right? So angle G2 will be 15 plus 75, and then you'll get 90 degrees. Are you together? Then the last question, they're telling us the length. Remember that, guys, I said to you, whenever you read the word center in Euclidean geometry, the first thing that should come into your mind is excuse me, the first thing that should come in your mind is two theorems. We already used the angle at center, but now we know that we can use the other theorem, right? Because it simply states that and if a line drawn from the center perpendicular to the chord, that line bisects the chord. So now I know for a fact that TG is equal to GS. Right, together. I'm given the length of TS at the square root of 80, which is 4 root 5. Let me confirm with my precious calculator. Square root of 80. Yeah, it is 4 root 5. It simply means that TG is equal to 2 root 5, and then GL is equal to 2 root 5. When I add the 2, I'll just get 4 root 5. Okay, but how can I write that here? Okay, since I've proven that G2 is 90 degrees, I can therefore conclude that OG, the line from the center, is perpendicular to TS, the chord. Why am I saying that? Because G2 is equal to 90 degrees. Are we together? So if this thing is true, I can simply say, therefore, TG will be equal to GS. The line drawn from the center perpendicular to the chord bisects the chord. Right, together. You can just write line from center perpendicular to chord TS. Are we together? So therefore can simply say TG is equal to 2 root 5. TG will be equal to the half of TS. Okay, this is how you would have answered the question 8, guys. Now, and then now let's go and answer question 9. Initially we are given the triangle ABC below, and we are told that M is a point on AB and N is a point on AC, such that MN and BC are parallel. Okay, here we are supposed to prove the theorem that states that if a line is drawn parallel to one side of a triangle, that line divides the other two sides in the same proportion. The first thing we must do, we must construct the heights, because we are going to use areas of a triangle, right? We can name this H1. Then another thing, construct another height, name it H2, right? And then since we are concerned about the sides, these two sides and these two sides here, that means we must make them bases of our triangles. Are we together? So how can we do that? We need to construct another lines here, like this, and then we construct another line like this. Why am I doing that? Because I want us to focus on this triangle. Right, together, and I want us to focus on this triangle too. Are we together? So that we can refer these to these as bases. Are we together, guys? Okay, now let's just prove. Okay. Whenever you prove, we will use the quotient of the areas, right? Okay, we can simply say the area of triangle AMN all over the area of triangle MNB, and is equal to 1 over 2. Our base is AM, and our perpendicular height is just H1, right? Then here we have 1 over 2 multiplied by MB, and the height is still H1. So here the halves will cancel, the H1 and the H1 will cancel. We'll simply have AB, not AB, rather AM. Why did I write AB? AM over MB. I need to fix the error there as well, because I wrote AB. It should be AM. Alright, together. And now let's focus on these sides again. We have the area of triangle A and M divided by the area of triangle NMC. This will be equal to 1 over 2 multiplied by AN multiplied by H2. At the bottom it will be 1 over 2 multiplied by NC multiplied by H2, and then the halves will cancel, the heights will cancel because they are the same. We will be left with AN over NC all together. But please guys, these two areas are the same together, because they talk about the same triangle but it's named differently together. So we can therefore conclude that the area of triangle AMN is the same as the area of triangle ANM, because it's one triangle but named differently together. And we know that the quotient of the triangles between parallel lines is always equal to 1 together. So it simply means the area of triangle MNB divided by the area of triangle NMC is always equal to 1, because these are areas between parallel lines. Ne? So this thing simply means area of triangle MNB is equal to the area of triangle NMC, which simply means that whenever I divide the area of triangle AMN to the area of triangle NMB, I will get the same answer if even when I take the other areas of the triangles. Why? Because I've shown that this is equal to this and this is equal to this, right? So I'll just say area of triangle A and M over the area of triangle AN NMC, right? But remember that whenever I calculated the area of triangle AMN over the area of triangle MNB, I found that AM, those two are equal to AM over MB, and then these two are equal to AN over NC. Alright, together. So this is a proof, ne, guys. Simply means if we have a line parallel to one side of a triangle and if that line it's inside that triangle, it simply means the same line divides the other two sides in the same proportion. That's your proof there, guys. Now, okay, and then now 9.2, we are given a diagram below, and triangle PQR is drawn. EG is parallel to, EG is parallel to QF, and EF is a straight line. Okay, the ratio of QE to ER is 2/5. Okay, it simply means if this is 2x, that will be 5x, right? And then the entire length will be 7x. Okay. PR is 49, FG is 10. Okay. Calculate, giving reasons, the length of GR. Okay. How can we find GR? We can simply say GR over FG is equal to ER over QE. Ne? This thing is true because of the proportionality theorem we've just proven, and the prop theorem is true because QF is parallel to EG, to GE or EG. Are we together? Okay, we don't know the length of GR, but you know that this guy is 10 units, right? ER will be 5x, and then QE will be 2x, but I don't need to write the x's because they will eliminate one another. So I will be left with excuse me, guys. So I will be left with 2GR is equal to 10 times 5 is 50. Then GR will be 25 units. Yeah, GR will be 25 units. So now I know that a GR is 25. Right? Okay. Okay, now I'm supposed to prove that let me erase this. I'm supposed to prove that FE is parallel to PQ. FE will be parallel to PQ if the ratio of PF to FR is the same as the ratio of QE to ER. How can we do that? Okay, we know that the entire length is 49, right? So 49 will be equal to 10 plus 25 plus the length of PF. So 49 minus 35, I think it will be 14. So the length of PF will be 14 units. Right, together. So this is 14. Are we together? So if I can show that PF, okay, let me write this thing here. Ne? If I can show that PF over FR is equal to QE over ER, I can therefore conclude that this guy will be parallel to this guy. Why? Because the corresponding sides are in the same proportion, according to the inverse of proportionality, right? Not corresponding sides rather, but the other two sides will be in the same proportion. Okay, let's go. PF over FR is equal to 14 over 35, right? Because FR is 10 plus 25, which is 35. Okay, so this will be 2 multiplied by 7 over 5 multiplied by 7. The 7s will cancel. I'll be left with 2 over 5. It simply means that the ratio of PF to FR is 2:5. Please remember that I was given the ratio of QE to ER as 2:5. This guy was given to me there. Are you together? So I can simply say, therefore, PF all over PF over FR is equal to QE over ER. They are both equal to the same ratio, which is 2/5. So I can therefore conclude that line FE is parallel to PQ. Why? Because of the inverse, not inverse, rather the converse of prop theorem. And the converse is true because PF over FR is equal to QF over ER. Are you together? The converse will be true because of that. So now I have proven that FE is parallel to PQ. Why is it parallel? Because this ratio, this guy over this one, is the same as this one over that one. So that means these two are parallel. Okay, now let's move on, guys, to question 10. Question 10, I'm given the diagram below. I'm told that A, B, C, and D are points on the circumference of the circle. PC and QC are drawn from P and Q respectively and intersect at C. Okay. I'm also told that QP is joined. Okay, DP is parallel to PQ. I told you guys, whenever you are told about parallel lines, you will either talk about alternating angles, corresponding angles, or co-interior angles. Sometimes all three in one question. Are you together? And then we are told that QB is 5 times BC. Okay, so this is 5 times x. If BC is x, that means QB will be 5x, and the entire length will be 6x, right? Okay. Now I'm supposed to prove that excuse me, CT over PC is equal to 1 over 6. I know for a fact that CT over PC is equal to PC over QC. This is true because of the prop theorem, and that prop theorem exists. Why? Because line DB is parallel to line PQ. Are you together? Remember that if I said BC is x, simply means QC would be 6x, right? This thing is equal to CT over PC. The x's will cancel. I'll be left with 1 over 6. Therefore, CT over PC is 1 over 6. Are you together? I've just proven that using the proportionality theorem. This guy is equal to 1 over 6. Okay. Secondly, I'm supposed to prove that triangle QAC is similar to triangle QBD. QAC and QBD. Okay. I'm comparing two triangles, right? I'll simply say in triangle QAC and triangle QBD, ne? Angle Q is there in both of the triangles, so this will be the common angle in both triangles, right? Okay, and then angle C will be equal to angle D. Why? Because they are in the same segment, they come from the same arc AB, right? Together like that. Those two angles are angles in the same segment, right? Okay, so simply write angles in same segment. Okay, and this thing will make the other two angles be equal by default. All right, so angle A1 will be equal to angle B2. This will be the third angle of a triangle, and therefore I can conclude that therefore triangle QAC is similar to triangle QBD. Why? Because these two triangles are equiangular. Together, if two triangles are equiangular, and then it simply means that those triangles are in the same proportion. Okay, now I'm supposed to show that QD times QA is equal to 30 times BC squared. How can I do that? Okay, the theorem, guys, it goes on. It doesn't end when triangles are similar, né? It says if two triangles are equiangular, therefore those triangles will be similar. And when they are similar, it simply means that the corresponding sides are in the same proportion. What are corresponding sides? Corresponding sides are angles which subtend, are sides which subtend equal angles. Okay, let's first focus on triangle QAC, right? Triangle QAC, this triangle over here. Are you together? Angle Q is subtended by what? By AC. Are you together? Angle C is subtended by what? By QA. And then angle A1 is subtended by QC. Okay, now let's go to the other triangle. The other triangle, which is triangle QBD, right? This is the triangle we are talking about. Okay, the first angle we spoke about was angle Q. Angle Q is subtended by what? By BD. Are we together? And then angle D is subtended by what? By QB. And then angle B2 is subtended by QD. Are you together? So from this, you can simply say AC over BD will be equal to QA over QB and QC all over QD. Are you together? I want to write them in different color to show that these corresponding sides do not come from one triangle. Ne? The corresponding side, one should come from the other triangle and the other side should come from another triangle. Are you together? AC goes hand in hand with BD. QA goes hand in hand with QB. And then QC goes hand in hand with QD, right? In our answer, we are not going to use this part, so we might as well just erase it. Are you together? Might just as well erase it. And then the statement is true because triangle QAC is similar to triangle QBD. Are you together? And then we can cross multiply here, guys. Ne? We can find that QD multiplied by QA is equal to QB multiplied by QC, right? Remember that QB, guys, is 5 times BC. We were told there QB is 5 times BC, right? So whenever I see QB, I can substitute 5 times BC, and whenever I see QC, QC is this entire length. It simply means that QC is 6 times the length of BC. So I'll just write 6 BC. Are you together? There I still have QD multiplied by QA, and QD multiplied by QA, excuse me guys, this will give me 30, because 5 times 6 is 30. BC and BC will give me BC squared. So I have proven that QD and QA is 30 BC squared. Thank you guys for your time. I hope this video was fruitful. Please stay tuned and wait for more videos, guys. Thank you.